We will have an industry talk here at AU 2020 where we will give you an insight into how we've been working with generative design at the European housing development company Bonava. We will tell you our story about how we implemented generative design for informed decisions within the organization. So again, very welcome to our presentation, Connecting People and Algorithms. My name is Sofia, and I'm graduated from Chalmers University of Technology in Gothenburg, Sweden. I have a Master in Architecture and Urban Design and a Bachelor of Science in Architecture and Engineering. I'm also a big fan of programming, so with a background in both programming and architecture, as well as engineering, I combine algorithms and design logics in order to investigate wide design scopes and in order to enable data-driven decisions.
Hello, everybody. My name is Erik, and I also have a bachelor degree in architecture and engineering from Chalmers University of Technology in Gothenburg, Sweden. And I'm currently doing my master thesis in complex adaptive systems, where I want to see how machine learning can open up new possibilities within architecture. And I'm especially interested in how big quantities of data can be processed and used to understand what we are building.
Hello, and my name is Anita Apala. As my colleagues Sophie and Eric, I'm also coming from architectural background. I hold a master's degree in architecture from Riga Technical University, but for about 2 years I'm employed by Bonava as a BIM specialist, where I try to bring my professional experience as an architect into building information modeling, find a way to work more efficiently, and implement best practices in the organization. So now you're familiar with us, and let's introduce in more detail what you're going to hear today. Just before tackling the main topic of generative design process itself, we felt it is important to include also a short introduction of what we as a company do and how the VDC is structured in our organization, because those were actually quite important prerequisites for development and evolution of generative design. In the main section, we will talk both about technical part, algorithms, and how they are applied on single family and multifamily housing, and also how specialists from various disciplines are involved in this process. We will share what we have learned and conclude with how we are going to apply these lessons for future steps. So without further ado, let's start. Who we are. Bonava is a multinational company and the leading residential developer of affordable housing units in Northern Europe in 8 markets. As you can see in the map on the right, we are in Germany, Denmark, Norway, Sweden, Finland, St. Petersburg in Russia, Estonia, and Latvia. And actually, this presentation is also recorded from countries lying on the opposite shores of the Baltic Sea. Sophia and Eric are in Gothenburg, Sweden, and I am in Riga, capital of Latvia. So Bonava as a company has been established 4 years ago, but has its roots in experience in building single-family housing and multifamily housing since 1930s, while being a part of NCC. Our vision is to create happy neighborhoods for the many, and thus our mission is to challenge ourselves to change the housing game to make that vision true. This presentation you see today is of an attempt at doing exactly that. One of the strengths of Bonava is that we are active and have control across the whole value chain, from purchasing the plot until handing over the keys to the customer. And by doing this, we can control and support the customer journey fully. And of course, also in business, any process improvements will be noticeable in the further steps. And thus, for us to be successful as a business and provide homes for the many, we need to increase our efficiency and decrease the time it takes to finish the projects. Therefore, digitalization was an avoidable step, and virtual design and construction was the key enabler for achieving our goals. VDC, or Virtual Design and Construction, is a familiar term, yet how exactly that's implemented in the company might vary. For us, it revolves around the core principles based on standardization, modularization, and industrialization. And an important concept we have in Bonava is a Bonava part. So what exactly is it? It is a predefined element which originates in Revit as a 3D model and later is given a unique identifier that we call a Bonava part ID. In this slide, you can see that it can be a single element, such as wall, or an assembly of elements, for instance, stairs. It also can be a whole predefined room, like bathroom. And all of these elements make a building system. So each of Bonava country has their own collection of Bonava parts that, together with descriptions of their applications and technical solutions, make a building system. As mentioned, Bonava part is a predefined element, and with the help of Bonava part ID, it is recognized in other systems we use for modeling, visualization, cost calculation, purchasing, and production. So the parts are defined, but what varies is how they are combined. And this is when generative design comes into the play. Even though we have predefined many elements, to such a degree that we already have parts for single-family housing units, the complexity of designing a building, or more so, a neighborhood, still remains. There is just so much aspects to consider and take into account, and correlations between them might not be apparent, but crucial for a development project. In the traditional design process, we design first and get evaluations of the proposals afterwards. In that way, we can do a comparison of few alternatives. What generative design allows us to do is to look at the multiple results first, see how various aspects affect the design and those results, and then pick ones that best fit to our goals and requirements.
Thank you. As Anita just mentioned before, Bonava develops single-family housing projects, both in Sweden and Germany. The houses themselves are defined as Bonava parts, and that is a perfect prerequisite for applying generative design. And that is also the reason why we started this development within specifically single-family housing developments. So, very similar to the traditional workflow of generative design, we came up with these 4 defined steps. First, we have the setup phase, followed by the generate phase, then we have the evaluate phase, and in the end, we have the select phase. But we approach this in a slightly different way than the traditional workflow. And we will guide you through the steps and tell you our story and how we apply this within the early stages developments. The first phase is the setup phase, and it is basically about choosing and formalizing rules and constraints for the project. On this slide, you can see the Bonava parts representing a single-family housing unit. The parts are predefined, and together they build up a set of modules to be combined within generative design. Since the houses are defined, the variable that remains flexible is the site. So therefore, our input is the site itself, together with a Bonava part and together with certain rules and regulations for how we can build and how we can combine the parts. So based on these 3 inputs, we created an algorithm that shuffles the Bonava parts and provides us with a wide range of possible site layouts. Each and every configuration is evaluated based on certain criteria, and Eric will guide you through all of this later on, but for now, let's have a look at the inputs. So let's have a look at the rules and constraints. As previously mentioned, the Bonava parts are predefined, but we also need to predefine how we can combine these parts. And in our case, we said, okay, no horizontal displacement is allowed. We can only have a vertical height difference of 0, 250 or 450 millimeters between two houses in a row. And we also need to specify how many houses we can have in a row. And in this case, we said approximately around 3 to 6 houses in a row. So that is rules and regulations related to the Bonava parts itself. But we also need to specify how these parts are related to the neighborhood and to the site. So we specified the dimensions of the gardens. So we specify the front yard, we specify the backyard, and we also place access points because we need to specify that point in order to place the houses on the site. And due to certain regulations in Sweden, due to fire regulations and accessibility rules, we also need to specify the distance between two house rows. So we need to specify rules on certain levels, but after we've done that, we can bring that knowledge and bring these numbers into the next step, which is about the algorithms. We developed this tool and this workflow 2 years ago before generative design in Revit was released. That is one of the reasons why we don't present a workflow fully integrated in Revit. And another reason, just like our topic of the whole presentation, connecting people and algorithms, we wanted to expose generative design for everyone within the organization, not only the Revit users. In Bonava, we believe that we have so much knowledge from different disciplines, and we basically wanted all that expertise to be the input and the design to be our common output. And therefore, we are using a web browser for exploring the results. In order to connect people and algorithms, we need to build trust in what the algorithm do. We need to ensure outputs similar to what we as humans would come up with. We discussed with architects, managers, design teams, project developers, and cost calculators how and why we design as we do. And we tried to translate this knowledge into algorithms so we could use it over and over again in order to assist the design teams and in order to generate wide design scopes. So, the first step in the algorithm is to define the zone for generative design. We also defined whether we have existing streets or where to connect new streets. Then we use the algorithm for street network generation, and this is mainly done by Voronoi, but it could also be used by rectangular grids or boundary offset, depending on what kind of neighborhood you actually want to achieve. And once we've created the basis for the network, the houses are placed recursively in the cells or the parcels that appear. Each and every house is placed together with a front yard, together with a backyard, and together with an access point. The access points are then connected with lines, and a big graph is created, where the access point represents nodes and the line represents edges. And then we can move into graph theory and use something called the minimum spanning tree algorithm. And we use that algorithm to calculate the shortest path for connecting all of the nodes in the graph. So what we then end up with is an efficient street network connecting all of the houses, connecting all of the Bonava parts. So, once we've done that, once we've defined the rules, once we've defined the constraints and we have the algorithm in place, the fun part starts. So we can now reuse the code written in C#, executed in Grasshopper. We can use that, and by just changing the input parameters and by just changing the seed a little bit, we can achieve a wide difference between outputs. We can create organic street networks or street networks, and thereby we end up with two very different appearances within a neighborhood. So we generate one alternative and we store that in a database, but we can generate even more alternatives or more. And in the end, we generate around thousands of alternatives, and our intention is to do this even before land acquisition.
All right. So once we have created all these alternatives, we need a reliable way to be able to know which ones of these are good and that we want to continue developing. And we also need to know for the alternatives that we do choose to develop further, what can be improved on those alternatives. And this is where the evaluation step comes into the process. So when we first started this initiative, we sat down in a workshop and we created 6 different categories of goals. And the first category is the number of houses, or the house distribution. And that's basically how many houses of each type we have in the neighborhood, and the distribution of different length of house rows, so the amount of pair houses and the amount of longer house rows. And then we have the ground data, and that is cut, fill, and mass balance. So the amount of volume you would need to dig to be able to build a specific proposal, and how much you would need to fill in the area. And the difference between these two is the mass balance. And then we have the parking parameter, and that's basically how much parking space we have in the area. And since we have both the possibility to build carports for the houses, but we can also use street-based parkings, it can vary quite a lot between different proposals. And then we have what we call sunny terraces, and that's basically how big proportion of all terraces are facing in a specific direction. And what we want to see is that we want to have a lot of backyards facing in the southwest direction. And then we have the street data, and that's first of all the amount of street area in the neighborhood in relation to all the other kinds of areas. But we are also looking at like the irregularity of the streets, like how curvy the streets are. And then we have the green factor, which measures the amount of green area or recreational area in the neighborhood in relation to all the other types of spaces. And to make these goals a little bit more easy to understand for people and for ourselves, we translated them into these 6 different cards that each represent one category of parameters. And so the project can choose which ones of these categories that they want the project to be evaluated on when we do the generation. So the next step is to visualize the data. And since we have different categories of data, we use different ways to visualize them. So first of all, we have the number of houses, and that's just a number, right? And then we have the distribution of different house types. So for this particular project, we only have 2 different house types, but it can be up to 5 different house types for a single project. And then we have the terrace orientations. And in the beginning, we actually tried to represent this with just a single number, so like a southwest orientation score. But we found that this created a lot of ambiguity between different alternatives, and that it's better to actually use to be able to see how many houses are facing in each of the directions. And then we have what I think is the most interesting diagram on this page, and that's the parallel axis diagram, where each alternative is represented by a line. And what's interesting about this way of displaying the data is that you can, in an easy way, put multiple alternatives on top of each other. And by doing this, it's easy to see how they correlate to each other. And especially when you add more and more alternatives, you can actually see trends starting to form. And you can see that certain parameters might have a positive or negative correlation. So the most obvious example for this is probably the cut and fill and mass balance, that those 3 are connected in a certain way. But it can also actually be seen in more or in less obvious parts of the diagram. So how certain parameters that you think wouldn't be correlated actually have a strong correlation. And what we do is that we actually use a lot of different alternatives at the same time, and we display these alternatives in a web-based design exploration tool called Design Explorer. So we visualize lots and lots of different alternatives at the same time to be able to see how they actually correlate to each other and what advantages and disadvantages certain alternatives might have. And on Design Explorer, it's also easy to see that these alternatives actually correspond to the cards that we talked about earlier. That here, for example, the first three parameters are the groundwork parameters, and then we have a couple of parameters connected to the house data, the amount of houses for each of the different house types, and the number of pair houses and row houses. And then we have the street data parameters and so on. So when you see this tool, I think that the obvious question to ask yourself is, who is this tool actually for? Who's going to use this tool? And this was actually the same question that we asked ourselves when we first started this initiative. And we sat down and tried to think about the user for what we were developing. And our realization was that we have a lot of competences within the organization, within different disciplines, and that every discipline has their own priorities, and every person within that discipline has their own priorities. And there is absolutely nothing wrong with that, but sometimes it might be hard to see beyond the parameters that affect what you are working with. So in this schematic example, we have the cost calculator that might be really concerned about like the number of houses that we are able to build in a specific area, and how much groundwork it will require to execute the project, while maybe the sales and marketing team might be much more concerned with the amount of green area that we can fit into the project, or how big proportion of the terraces actually face southwest. And what makes this even more problematic is that the traditional workflow is oftentimes quite linear. So and certain disciplines comes in to the design process earlier on in the process than other disciplines. So a decision taken in the early stages might actually affect something that happens much later on in the project. And it might be possible sometimes to go back and change the decision when new information has come up. But in practice, it's rarely possible to do so because it would require so much reworking of the project. So it's not economically feasible to do so. And what we want to do is to, instead of having this linear workflow, we want to have a much more circular workflow where people from different disciplines can sit down around a table and look at the evaluations and take informed decisions. And we believe that doing it in this way makes it easier to see how things that are not obviously connected actually are connected to each other and how they affect each other. And we think that it also gives people the authority to argue for moving the project in a certain direction, because you can substantiate your arguments with numbers and facts, right? And we believe that we can by doing this create a better end product for the customer. By doing this, we can also make the decisions that we take. We can make the decisions earlier on in the design process, and in the ideal case, we can even evaluate the proposal before we actually have bought the land. So we can, by doing this, reduce the risk of the project quite a lot, and we can make sure that we actually invest in the right types of projects. So once the design exploration team has picked one or a few alternatives that they think are especially interesting and that they want to develop further, it's time to go into the next stage of the generative design process, which is to select alternative and bring it into Revit. But before we look at how that actually is done, I want to quickly summarize what the data flow looks like. So here we have a schematic representation of the data flow. So we start in Revit, where we set up the project and where all the Bonava parts and the houses lives. And then we use Rhino inside Revit to bring the data into Rhino and Grasshopper, where we generate the alternatives. And we push all the data associated with each generated alternative. So both the geometry and the evaluations to a database. And we also capture pictures for every alternative that we can use in the visualization. on Design Explorer. And then once the Design Exploration team has chosen which alternatives they want to continue working on, we bring those alternatives into Revit using a custom script. And now we're going to show you how the Revit import is actually done. So we start by opening up a custom script from within Revit. And we have written the script so that you don't need to actually interact with Rhino or Grasshopper, but it just brings up a window where you can log into your project page with the specially created username and password for that specific project. And then you can choose the alternative ID to see what that alternative actually looks like in 3D. And first, it brings the alternative up inside the pop-up window, and you can pick another alternative that you want to have a closer look at. So it brings in all the data, both the geometry, but also the evaluation data. So you can see here, for example, the number of different house types that you have in that particular alternative. And then when you click import to Revit, it brings all the geometry into Revit, and you can keep on developing the alternative further from there.
All right, so this is how a model might look after the import. We still have to do some manual adjustments for house placement, but most of it will go together with the landscape design, when we also add common buildings and areas, design streetscape, and add landscape elements such as playgrounds, lighting, furniture, planting, and so on. So what you can see are lot 200 Revit families, or as we call them, Bonava parts that represent a single family house type unit. We use them in the planning phase, but after that has been finalized, we record their coordinates and use a set of scripts to link actual building models. And in those, we have already prepared all the documentation necessary for building permits and also material for sales and marketing department.
All right, thanks a lot. As Anita just mentioned in the beginning of the presentation, Bonava develops single-family housing and multifamily housing projects. You have now seen how we implemented generative design on single-family housing. So let's now have a look at how we approach generative design within multifamily housing development. Just as Anita mentioned, a single-family house is represented by a Bonava part. But that is not really the case for multifamily housing. We are not working with type houses. Instead, we have predefined parts but in other scales. It could, for example, be a predefined bathroom or a kitchen module. But it could also be a stair or a wall, as mentioned in the beginning of this presentation. Since the parts and the sizes of the parts vary a lot between single-family housing and multifamily housing, one can understand that the design processes work differently for these two cases. Since everything within a single-family house is predefined, we do not need to deal with the interior while placing the houses on the site. However, for multifamily housing, we do need to take two perspectives into consideration at the same time. We need to deal with the exterior perspective, meanwhile we ensure the internal requirements and qualities are being met. This is normally embedded in the architect's expertise, but can in certain cases result in complex and quite time-consuming processes. Since there are so many aspects to consider, we are applying generative design and algorithms as a way to assist the human brain, facilitate decision-making, and in the end streamline the planning. The way we are approaching this complexity is by dividing it into two parts and deal with the interior and the exterior challenges separately. As mentioned, we have predefined kitchen modules, and by placing these modules in different ways, we end up with several spatial representations of kitchens. It could be a parallel kitchen with a dining on the short edge, it could be an L-shaped kitchen with a dining table in the middle, and so on. So by combining kitchen modules, we can, with the help of algorithms, create possible room shapes suitable for our Bonava parts. We can do the same things for the bathroom, but in this case we are not shuffling the items inside the spatial representation. We are working with predefined bathrooms, and we already know where each and every item inside the bathroom is placed. Let's keep that in mind and go to the next scale. Let's move up one step and let's have a look at the living unit perspective. You can create living units, aka a floor plan, in a lot of different ways, and we have been looking at procedural algorithm for subdivision. We've been investigating neural networks and GAN approaches, but the approach we are currently investigating is to recursively place the rooms in order to make sure that everything fits and works together with the Bonava parts. So we are now working on an algorithm for combining predefined rooms according to certain rules. Of course, we are dealing a bit with graph theories here, since we need to take adjacency preferences and also circulation aspects into consideration. The work is still in progress and it's not perfect, but we still want to share our ideas in order to exchange knowledge and experience and open up for discussions. But anyhow, what we are then doing is that we store every possibility of a living unit in a JSON format in a MongoDB database. We store the geometry, but also relevant metadata such as square meters, type of kitchen, type of bathroom, and how many people the apartment is suitable for. We build up a reference bank of possible units that we later on in the process can use for assisting us as human in a complex design process. So if we switch perspective and look at the exterior, we can use this dataset as an autocomplete tool. Once we subdivide the volumes, once we place the core functionality such as staircases, elevators, we can refer to the dataset and get information about the possible floor plans for a given apartment boundary. Of course, we are taking the entrance point and facade position into consideration as well, and we are currently working on the shape matching algorithm for finding the most suitable living unit for each and every container. So to sum up, this is again a way of connecting people and algorithms. We are letting the computer do what it's best at: computing, storing, handling big data. We should see the rise of using algorithms and AI as a way of enhancing us, not replacing us. We are using algorithms here to assist the design team and in order to make more informed decisions. And we should see this as an evolution rather than a revolution.
Thank you. So now you have seen what we have created so far. And let me say, there has been a lot of experimentation, trials and errors to achieve these results. So what we can learn from that? First, it didn't happen in one day. There has been a gradual development of digital tools since Bonava was founded. And we started simply with content creation and reuse of the same parts. We then looked into how we can automate some of these tasks by writing scripts and developing specific tools that would allow to speed up standardized and repetitive processes. Last year, we looked even further and started to investigate generative design. We came out with developing tools for optioneering, and now we are looking in how to apply genetic algorithms for design optimization, or in other words, how to make those options better. But genetic algorithms might be not the only solution. Before we jump into next technological developments, we stopped and did some reflections, which in the end we could put in three categories. First, design. We noticed that generative design boosts creativity because the scripts might produce the design alternatives that might not be obvious yet still perform well. Also, it indeed is fairly quick to produce many options, but even when the best one is chosen, the design is not final and still needs architect to improve on it. But it is a rather good basis to start with. And last but not least, is that we can also find ways to quantify soft values. In our case, those were sunny terraces. And now also this aspect can be brought to discussion table, which leads to the next category, communication. As Eric mentioned, now we can bring different disciplines together earlier. And because we can see the correlation between various results, it allows to understand better why some discipline favor one option over the other. That makes decision making more transparent, and everybody has a holistic perspective of the project. When it comes to technology, we realized that writing a code for designing a site might not be the same as writing the script for automating repetitive process. Even though fundamentals do not change, each site comes with its own unique challenges, and we had to customize code for it. On the positive side, it also pushed us to constantly evolve. At that point, we also noticed that we want to write a code for everything, but some things are easier and faster to do manually because what we call a common sense might take thousands of lines of code.
So now I'm going to talk a little bit about what's next in this initiative and what we think are the best future steps to take to make our tools even better and more useful in the organization. And what we're working on at the moment is to incorporate the Sustainable Development Goals from Agenda 2030 into our tools. So what we did was that we identified the two goals that we think are the most relevant for us, which is number 11, sustainable cities and communities, and number 13, that is climate action. And we thought to ourselves that we have these cards that we are working with, so why can't we just incorporate these two sustainable development goals as capabilities in the cards? So we will create one card that is based on climate action, and it can contain capabilities such as embodied carbon dioxide equivalent and energy consumption. The energy consumption, for example, is really interesting because the thermal properties can alter quite a lot depending on the materials and the design that is chosen in the early stages of the project. And it can give great effects on what the actual lifetime assessment of energy is for the building. And then we have the sustainable cities and communities. And there we have, for example, accessibility that we have started to look at a little bit. And that can, for example, include themes such as how accessible the neighborhood is to people with certain disabilities, or how accessible community services are in the vicinity of the neighborhood. And then we have also started to look a little bit at perceived safety, which is about how you are feeling when you are walking around in your neighborhood. If you are feeling safe, or if there is certain parts of the neighborhood that feels more threatening or less safe than others. And sometimes it can be a challenge to translate soft metrics and things that you perceive into metrics, but it's something that we are going to continue working on and try to make better. And we think that the best way to do this is to build experience from projects that are actually being built and compare them to what we are calculating in the early stages. And we want to do this by creating a feedback loop between what we actually calculated and the results from the calculations, that is the built neighborhood. So, for example, if the design exploration team have chosen a specific alternatives to develop further, we can look at how they came up with this alternative, what parameters they look at, and we can actually save that data into a database. And by seeing how people are using our design tool, we can see what parameters are useful, and what things are considered and not considered in the early stages. And we can perform data analysis on this data. And of course, this is being done together with a continuous discussion with the design and exploration team, and to be able to see what is actually appreciated and what should be further developed in the future. And then we are thinking that the next step would be to actually be able to evolve alternatives. So we can use the save filters to combine multiple alternatives with certain advantageous parameters and create one alternative with certain properties from alternative A and certain properties from alternative B, and get even better result in the end. And then we see it as that if we can create this, we can also create real-time design suggestions. So we can learn from previous experience and mistakes, and we can give the architect clever suggestions while he or she is working with the design and sketching. And this can help the architect to find non-obvious solutions to a problem with a lot of free parameters, basically. So it's really all about creating workflows that are proactive and gives people working with the design the tools to create a good design and a good product for the customer in the end. So we are starting to approach the end of this presentation, but we have one last really important question to ask, and that is, what is it that we are actually creating when we are doing this? Is it an evil robot that just wants to take all the decisions for itself? Or is it good to have a digital assistant that can help people with different backgrounds from different design disciplines to understand each other better and to together take better decisions that results in better designs and homes for the customers? And I think we need to have this question with us in every step of the way in the development to always take the right decisions. And we like to think that what we're actually creating is this good to have digital assistant. And we are trying to do this by always having an ongoing discussion with people from different parts of the organization to hear what their experiences with the tool is and how they think that we can improve it in the future. So ultimately, what we're trying to do is not only to connect people and algorithms, but actually connecting people with algorithms. And I think today this is probably more important than ever with the current situation in the world. So lastly, I would like to thank you all so much for joining us here today to listen to how we're using generative design in the early stages here at Bonava. It's been a pleasure and a privilege to be part of this conference. And I think that together we have so much knowledge. And I believe that by learning from each other, we can really change the housing game and we can create better lives for the many. If you have any questions or if you want to get in touch with us for some other reason, there will be a page where you can ask questions that you probably already know about. And you can also find our contact details in the presentation handout. Thank you so much for listening.